Integration by Parts by Abby Cott, Carmen Prestman, and Daniel Gutierrez. When given the integral of x sine x dx, how do we find the answer? Since neither one of these equations are related using antiderivative or derivative, we have to use integration by parts. The general formula for integration by parts is the integral of u dv equals uv minus the integral of v du. The steps: 1. Identify your u and dv. 2. Find du and v. 3. Plug the terms into the formula. 4. Integrate the integral of v du. 5. Simplify. How to figure out what's u and dv. The natural log of x is usually u. Otherwise, the polynomial is u. E to the x is easy to derive and integrate, so make your decision based on the other function. The integral should get simpler. Step 1. Identify your u and dv. Given this equation, we know that u equals x and dv equals sine x. 2. Find du and v. We know that u is x, so du is 1. We know that dv is sine x, and so v is negative cosine x. 3. Plug the terms into the formula. The formula, remember, is the integral of u dv equals uv minus the integral of v du. So with the numbers we found out, we can plug in and get the integral of x sine x dx equals negative x cosine x minus the integral of negative cosine x1 dx. Step 4. Integrate the integral v du. The integral of v du equals the integral of negative cosine x1 dx, which equals negative integral cosine x dx, which equals negative sine x. Step 5. Simplify. The integral of x sine x dx equals negative x cosine x minus negative sine x plus c, which equals negative x cosine x plus sine x plus c, which equals sine x minus x cosine x plus c. So the final answer is the integral of x sine x dx equals sine x minus x cosine x plus c. Now here's a harder example. When trying to find the integral of x squared e to the x dx, u, is x squared, and so du is 2x. dv is e to the x, and so v is e to the x. So you plug in, and you get x squared e to the x minus the integral of 2x e to the x dx. And this last part needs to be integrated by parts again. And so when you integrate it again, you find u to be 2x, du to be 2, v to be e to the x, because dv was e to the x also. So you plug in again the values, get x squared e to the x minus 2x e to the x minus 2 integral e to the x dx. Make sure you bring the 2 outside of the integral because it is a constant. And then your final answer is x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Always remember to add c to the end. The tabular method. 1. Find u and dv. 2. Create a 2-column chart. Put u on the left side and dv on the right side. 3. Take the derivative of u until it reaches 0 or becomes more complicated. 4. Integrate dv the same number of times. 5. Connect each term diagonally and the last row horizontally. 6. Alternate signs and write the solution. This is faster than using the integration by parts multiple times. And here's how you do it. So when trying to find the integral of x squared e to the x dx, you find u to be x squared and dv to be x. And so you find the derivative of x squared until it reaches 0 and find the antiderivative of dv until the same amount. Then you cross down and go the last one across. And you get the answer to be x squared e to the x minus 2x e to the x plus 2 e to the x minus the integral of 0 e to the x dx, which is 0. Thanks for watching. The end.